All right. Welcome, everyone, to AIM303. Who's excited to be a reInvent this year? All right, one more time. Who's excited to be a reInvent this year? There we go. Well, we are thrilled to have you here in person tonight and virtually for those that are in other rooms. We're going to be talking about customizing foundation models using SageMaker. I'm Carl Albertson. I lead our product management teams for SageMaker and Bedrock Inference. I'm joined by Mark Karp, who's one of our solution architects for SageMaker, and Maren Kurian, who is a distinguished engineer with Intuit. OK, so why are we here tonight? I suspect that many of you in this room have started to test off-the-shelf foundation models. And I suspect that many of you in the room have also started to push the limits of what can be done with those, whether that be the performance gains you're trying to get, the accuracy, or even the cost as you scale up for production deployments. And this is where fine-tuning those foundation models can start to play. So over the next 60 minutes, we're going to be talking about when it makes sense to fine-tune foundation models, how you can go about selecting those models and preparing your data, the capabilities that SageMaker offers to simplify a lot of the process for you. And then Mark is going to join on the stage. He's going to walk through a demo of how we can get started. And then Maren is going to join and talk about how Intuit is using fine-tuned models in production today in products that many of you probably use on your day-to-day basis. OK, so before we go deep, I just want to ground everyone with a typical foundation model workflow. So oftentimes, you're selecting many of the off-the-shelf models. You may be evaluating those against your specific prompt libraries or performance benchmarks. You may customize some of the deployments, and then you put them in for deployment. This is often a very iterative process. You're testing multiple model families. You're testing multiple model sizes. And then every 3 months, when new models come out, you have to do the whole process over again. So as we introduce fine-tuning into this cycle, it adds a little bit more complexity. But I think in many cases, this complexity is manageable and often beneficial. OK, so let's talk a little bit about when you would fine-tune the model, and then we can go into, are you ready to make this happen? So in terms of when it makes sense to fine-tune, as I mentioned at the beginning, if most of you are starting to push the limits, this will start to become obvious. So for example, let's say you're trying to improve the accuracy of your model. You're trying to get a proof of concept that is that level of accuracy and robustness for your specific use case. This might be specific to your domain, your function, or your business. And just the ones that are trained on open web data just aren't really doing it. So that's a great reason to fine-tune a model. Second, you have a very compelling proof of concept ready to go. But scaling that up to the traffic you expect in production is becoming cost prohibitive. So you're looking for how do you get more out of a smaller model, or similar or the same accuracy, but be able to save costs so that inference can be done economically and you can actually scale into production. Or third, you might have a very latency-sensitive use case. Say you have a chat use case where you need to have that quick response. So again, you might be looking for a smaller model that has the performance and the accuracy of a large model. Those are 3 great reasons to look at fine-tuning. On the other hand, when are you ready to fine-tune? I think this really boils down to 2 things. So one, do you have a unique and differentiated data set that's not going to be part of the original training corpus? And I suspect that many of you do. This could be your customer data that are engaging with your products and services. That's a treasure trove of information that you can use to fine-tune models. Or if you're trying to improve internal processes in internal use cases, this is where you can look at your documentation and really level up your teams and simplify the processes. Where I'm seeing a lot of customers get started is oftentimes the customer service and customer support use cases. A lot of the bars and barriers when it comes to toxicity in responses is a little bit more mitigated as you have internal use cases first. And you have a great depth of problems and answers and often the language and tone that's used to respond to customers. And so those provide very good data sets to start working on as you expand to more and more use cases about your enterprise and business. OK, so now you've got the reasons to train, or reasons to fine-tune, and the readiness to fine-tune. How do we actually go about fine-tuning? Well, it's actually a bit of a time-consuming, laborious process. You have to prepare your data sets. Then you have to select the appropriate instance type and set the configuration that's needed. Then you're going to go and select appropriate hyperparameters and probably have to do a lot of iteration to improve those over time. And then finally, you're going to have to write your evaluation scripts and set those valuation metrics. And then after that's all done, you need to pack these models and get them ready for deployment. So all of this is super time-consuming and, frankly, not very differentiated with what you're bringing to the table with your data and your knowledge. So this is where SageMaker comes in. SageMaker really does a lot of that heavy lifting, allows you to kind of get beyond a lot of those basics and focus on where you add the differentiation. And that's often the data sets we talked about that are unique to your business. It's the knowledge that you have of your customers, and it's the knowledge that you have of your products. And this is where you're able to focus on when you're starting to use some of those tools and services within the SageMaker suite. So I'm going to step through a couple of the key ones to help you get going. So first and foremost, within SageMaker, we offer hundreds of pre-trained foundation models, many of which can be fine-tuned. So we make it very easy for you to help find those models that can be used. So you can filter by model family, by model size, which of these models can be fine-tuned, so you're ready to go. We make that simple to do through an easy-to-use UI that can be discovered through SageMaker Studio in a product called SageMaker Jumpstart. Similarly, they can be very easily used within the SageMaker SDK, so this can be programmatically done as well. Furthermore, we've added capabilities to allow you to curate which models are surfaced within your enterprises. So we've gotten feedback that many customers want to control the types of models they make available within their teams. So they might want models of specific license types, specific families of models that they've vetted, or individual models. And so with the curation capabilities, we allow you to limit which models can be revealed or used by your teams to get going quickly with these approved models. And then lastly, all these models are actually being deployed from AWS infrastructure. And that means you can deploy them in sensitive environments, or you can deploy them into your VPC with network isolation, which is important if you're operating with sensitive data or sensitive environments. OK, so now we've selected our model or a handful of models that we want to start to use. So we're going to talk about kind of the data preparation that comes into play. And I want to spend a little bit of time talking about some of the types of fine-tuning, because it will differ how you're actually going to prepare that data. So one common use case is called domain adaptation, where you're taking a base off-the-shelf model, and you're improving it for the needs for your specific industry or function. So for example, if you're a legal company or a financial services company, you're feeding it more data that's just either legal documents, legal briefs, or it could be internal research for the companies that you're doing. And this is relatively straightforward in that you're providing the documents themselves, and it's a continuation of that initial training process, where it's just learning to predict that next token based on this new training corpus. Now, a little bit different is called instruction tuning. And here, you're providing specific question and answer pairs to the model. And in doing so, you're training the model how to respond to these types of questions. This is really helpful if you're trying to summarize information in a certain way that's used throughout your company, or you're trying to generate new data that follows a relatively common template. You can pre-train these models to follow those instructions, so when you present it with new information, it will follow those templates or follow those typical instructions. Now, the third one I put up there is called visual Q&A. So as models are starting to move beyond just text-based to more multimodal, is a similar process in that you're to instruction tuning, in that it's both a question and answer pair, but now you're adding that other layer of what's the image that goes with it. So that's initially how you prepare your data sets for those techniques. In terms of how you're actually configuring that data and sending it to the model, domain adaptation is probably the most straightforward. It's a simple text file. And instruction tuning or visual Q&A, it's a JSON format where you're specifically identifying the role that the model will play in that question and that answer pair. OK, so this is often the time when customers are asking me, how much fine-tuning data do I actually need to generate a good response? And most approach the problem thinking it's going to be in the magnitude of hundreds of thousands or millions, somewhere on that order of magnitude of the data set that the original model may be trained on. And I'm here to share some good news tonight, is that we're finding that actually much less data may be needed. So it's not always the case, but we're finding that in many cases, either just hundreds of examples or even sometimes less than 100 examples can have meaningful improvements in the accuracy of that fine-tuned model. So I share this with you to encourage you, depending on whatever the amount of data that you have, start by trying to fine-tune a model, and you might be very pleasantly surprised at the impact you can have with that relatively small data set. I want to add one more thing, which is customers are beginning to try more and more on using synthetic data to either create or augment their data sets. So if you don't have tens or hundreds of examples, you're not necessarily stuck. So we've seen some very compelling examples where customers have taken large models, so in this case it would be like a Llama's 405 billion parameter model, to generate very accurate responses to their questions or annotations of their data. They can then vet this with their human teams to make sure that those responses are indeed right for their domain. And then they have an excellent question-answer pair that they can use to feed in an instruction tune a much smaller model. So this is an example where what I share on the screen is you could generate those annotations or those answers using 405B model, and then an 8 billion model is a very common one that's used in production. You can use that question-answer pair to instruction tune a smaller model, in many cases get accurate results that can be scaled economically. Okay, so we have the reasons why we want to fine-tune. We've now prepared our data set. And then we actually want to go through with the fine-tuning itself. So on SageMaker, we have two paths to do this, and they're interchangeable. We have SageMaker Jumpstart, which is designed to be really the easy way to get started. It's a very simple UI experience where we have pre-written fine-tuning scripts, we have example data sets, and the hyperparameters already set with defaults that work very well for most cases out of the box. If you have a more complex training job or want full control of everything, SageMaker training will allow you to go as deep as you want. So either of those two paths are a great place to get going. I'm showing right here a screen snippet of the hyperparameters in SageMaker Jumpstart. There's a number of them. This is not meant to say, hey, there's a lot, this is confusing or daunting. This is meant to show you that we provide you full control at any moment to override or customize. But each of those, for the models that we offer fine-tuning, are filled with defaults that work very well, in most cases, right out of the box. I'm going to pick three, just kind of go through three that we find are quite impactful to both the fine-tuning process, to do the fine-tuning efficiently, and also generate high-quality results. So the first one would be a quantization. So this is a technique where you're actually going to reduce the floating point precision of the model. And we found that in many cases, you can actually, the accuracy of the model will not be impacted that much, but the memory footprint can be reduced substantially. And this allows you to both speed up the training process as well as a very efficient model to be running an inference as you go forward. Second, I'll talk about FSDP, or fully sharded data parallelism. This is a great technique that we offer out of the box that allows you to fine-tune very large models. It will shard the model for you, allow you to be used with multiple parallel workers, and make it very easy for SageMaker to be your backbone to fine-tune these very large models. And lastly, one that many of you are probably familiar with in this room is low-rank adaptation, or LoRa adapters. And so our scripts are able to use LoRa fine-tuning right out of the box. In this case, instead of actually fine-tuning every model weight in the model itself, we're fine-tuning a very small percentage of those, many times 1% or less of the model, which allows the fine-tuning process to happen very quickly, and the subsequent model can be used very efficiently. So those are just three examples of the many hyperparameters that we have. And in each case, we have smart defaults. So you could just look at this page, not read anything, and click go. And that fine-tuning job will start. But if you want to kind of go back and start iterating, go deeper, you always can as SageMaker. OK, so now that we've fine-tuned the model, there's one more step before we go to deployment. There's multiple model artifacts that need to be packed together. And with SageMaker, that's actually done out of the box. So as soon as a fine-tuning job is done, there's an option to either deploy that model directly behind an endpoint. SageMaker behind the scenes will take care of packing that model and setting it up. So you can take that fine-tuned model and put it immediately behind an endpoint for production use cases or further testing. And while I've talked a lot about SageMaker today, that's a fantastic option when you want to have full control over the instances you're putting in deployment. But we also know that many customers increasingly are building workflows around Amazon Bedrock. And I'm really excited to talk about that with Bedrock's custom model import. You can take the models that you fine-tune on SageMaker, import them into Bedrock, and then you can use them with the Bedrock invoke model and Converse API. And that can be then flown directly into your existing Bedrock workflow. OK, so with that, I'm really excited to introduce Mark to the stage. And Mark's going to do a demo, basically, of what I talked about and more to make this really approachable. So as you leave the session, you feel confident and ready to start fine-tuning models with your own data set. So thank you, Mark.
Cool, thanks, Carl. So let's now take a look at how to get started with fine-tuning on SageMaker, specifically using SageMaker Jumpstart. Now, at the core of fine-tuning on SageMaker Jumpstart is the concept of SageMaker training jobs. And if we take a look at what makes up a training job, we can see that it contains an ML instance. And this could be a GPU-based instance, CPU-based instance, or even an accelerator-based instance, such as Trainium. But in the case of foundation model fine-tuning, it is most likely GPU or accelerator-based. And then within that ML instance is an actual container. And that container contains the training script or training algorithm of your model. And the S3 input data that you're going to use to train the model will reside within S3. And then the pre-trained model weights themselves also reside within S3. And once training has completed, all the instances are terminated, and the resulting fine-tuned model weights are also sent to S3. So what does SageMaker Jumpstart do? Well, SageMaker Jumpstart essentially encapsulates all the fine-tuning scripts. It exposes a bunch of hyperparameters for you to test and tune, and it even selects some of the default instance types for you to get started for fine-tuning. And so, as Carl mentioned, a bunch of pre-built training scripts are supported out of the box for different types of models. There's a number of hyperparameters for you to test with, and domain adaptation, instruction-based, and visual Q&A is all supported today. So let's jump into a demo and see how easy it is to actually fine-tune with SageMaker Jumpstart. And in this demo, we'll explore two methods of fine-tuning, one using the SageMaker Studio UI, and another using the SageMaker Python SDK. So we're going to consider a scenario where we need to extract information from custom images, including both handwritten and printed content for document understanding and question answering purposes. So many organizations out there we've seen have unique documents, maybe forms and other images, that are unique to their organization that foundation models may not have encountered before. And that's where it becomes important that fine-tuning becomes essential to actually improve the overall accuracy of these models when understanding these custom images and documents. So we're going to use a multimodal model, a Llama 3.2 model, to accomplish this. It's the next generation of models that go beyond just text understanding, but now have the ability to actually understand images and analyze images for specific use cases. So in this case here, in this example, we can see maybe this is a custom image from an organization where we want to actually extract the name of the company and where it's from. So let's take a look at that. So we're going to start with the SageMaker Studio UI. So within SageMaker, in the left navigation panel, we can see the Jumpstart section. If we select the Jumpstart section, we'll be presented with a bunch of different model providers, both proprietary and open weight model providers. In our case, we're going to be looking at the Meta family of models. So if we select the Meta card here, we'll be presented with the different Meta models available to us. In our case, we want to just fine-tune the Llama 3.2 11 billion vision model. So we can just search for vision. And we can see the different variations of that model, but just select the 11 billion parameter. Then once we're here, we can see the model card and details about the model, and so on. But importantly, at the top, we can see two buttons, train and deploy. So deploying would deploy a pre-trained model, but train would actually allow us to fine-tune the model. And this is where we provide our S3 input data. So in our case here, we can just use an example data set that's provided by SageMaker. It's just a doc VQA data set. This is just a common data set used to evaluate vision models. Here it's got 3,000 examples with images with the ground truth answers. But if we had our own data set with our own organizational images, we can pass it as well. And then we can set those hyperparameters. So here we can select the parameter-efficient fine-tuning technique, such as LoRa, which just allows us to fine-tune on just a set of parameters instead of all the parameters of the model. We can see other hyperparameters, like if we're going to be setting any gradient checkpointing or BF16 mixed precision training, which just allows us to fine-tune usually in higher batch sizes and decreases the hardware requirements. And then we can select the instance type. Again, SageMaker Jumpstart is telling us which instance types are available, and we could select the default or change it. And then importantly, we can set the S3 path to where the resulting model weights will reside. And then some other configurations such as IAM role, VPC config, and encryption, we can also set if we like. So once we're done, we can click submit. We'll have to first read and accept the EULA. And once we've accepted that, the actual training job will be kicked off, and it will stay in an executing state. And then after some time, the actual training job will go into a completed state, and this is where we can actually see the performance of the job. So here we can see some evaluation loss and training loss, and also details about the artifacts that were used for the job, the input data that we used, the location of the actual fine-tuned model weights as well at the bottom there. And importantly as well, we can see the hyperparameters of that run. So if we see here, this job here ran for 5 epochs. And so another thing that we can look at as well is the actual instance that was used for the job, and also the logs for that training run. This is available in CloudWatch, but it's also getting pulled directly into SageMaker Studio. So that was the Studio UI experience, but we can also fine-tune using the SageMaker Python SDK. And so here I'll walk you through a notebook where we actually kick off the same training job, just programmatically. And so if we look here at the top of the notebook, we actually will set the model ID, in our case that 11 billion parameter vision model. I'm going to download also the data set here, the docvqa data set locally. And I'll create that metadata JSON file that Carl had mentioned. And I'll show that to you shortly, but essentially here's just the code to do it. I'm going to be using 1,000 train examples and about 20 validation examples. And to see what that looks like let's open up the metadata.json file. And this will essentially contain the reference to the actual image, right? From that docvqa data set, it will contain the prompt or the question, and then the ground truth answer that we're going to need for fine-tuning. And then in the image folder, will actually contain the actual images that the metadata.json file refers to. So, yep, once that's done, again, this is just 1,000 examples. We could pull more or less as we like, but once that's complete, we'll need to upload that data set, including the metadata.json, to S3. And once that's uploaded, we can just look at the default hyperparameters that are set by Jumpstart for this model. In our case here, we're going to override the number of epochs to 5. We can validate the hyperparameters that we've set. And then importantly, this is where we actually create the Jumpstart estimator. And this is where we provide that model ID, the model that we're going to fine-tune, some parameters like the instance type, the hyperparameters, and importantly, that training data set in S3 passed in the .fit method. And then the training job will run and complete, and then we can actually deploy the model programmatically as well with a simple .deploy method. But in our case, I think let's go and deploy the model via the UI. So here's that completed training job. We can simply click deploy. Once we click deploy, we're presented with the details of the endpoint configuration that we're going to deploy. We can set the endpoint name. We can also set the instance type, except the EULA, of course. And in our case, we can leave all of this defaulted as well. Jumpstart will automatically set all the configuration, the container, the environment variables for deployment, and prepackage everything so that you can simply just click deploy. Once that endpoint is up in service, this is when we can actually invoke the model and make inference against it. So what we'll do to actually showcase that is we'll actually look at how to do that programmatically using the SDK. So here I've got just some code to actually invoke this SageMaker endpoint. And here the prompt that I'm creating is from the validation dataset, where I'm going to pull the image as a base 64 encoded image. Right? I'm going to then provide some instruction to the model, basically telling it to read the text carefully and answer the question within the text as seen exactly in the image. And then some other instructions, just trying to get it to be more concise. And then importantly, I also pass in that question that's going to be asked for that image, and then I expect the model to actually provide a response. And so that payload for inference just includes a number of parameters as well that we set, just like application/JSON for input and output. I'll then load up the validation data set that I had created previously. And here I'll just invoke about 5 examples. So I'll just be using the predictor.predict method. I also have a pre-trained model also deployed, so we can look at the difference. So here we can see, for an example, what is the name of the university. So in this document, we can clearly see it's University of California. For some reason, the pre-trained model was not able to get it, but the fine-tuned model was successfully able to get the ground truth answer. Another interesting example is, so to who is the document sent? So this is the same document. So if we look, it even takes us a moment, but it's actually Paul. The pre-trained model was able to get it, but it seemed to have put some extra details in there for some reason. And then the fine-tuned model was able to correctly identify it as well. And then another example here is more like a document or form that's printed. So according to the budget request summary, what is the total amount of other expenses? So if we look here, the answer is $975 US. The pre-trained models seem to not get it, although it did mention it. But the fine-tuned model was able to successfully pull that and extract the correct amount. And then another example here is how many nomination committee meetings has S. Banerjee attended. So we can see that it will even, again, take us a moment to look into this and try understand the image. But if we zoom in, we can actually see that S. Banerjee attended 2 committee meetings. And we can see it there. And the pre-trained model, again, was able to mention it, but then seemed to just respond back with the question. But the fine-tune was able to successfully get that. And then finally, this is also an interesting one, is what is the number of persons present for the Sustainability Committee held on the 5th of April? So if we zoom in here to the 5th of April, we can see that the answer is 6, right? But for some reason, the pre-trained model decided to start counting, but the fine-tuned model was able to successfully pull the result. So as we can see, the actual accuracy in actually understanding the images and the documents greatly improved. And what we've seen is organizations that have these custom documents, custom forms, these pre-trained models have not necessarily been trained on them, and that's when, again, it becomes essential to actually fine-tune these models. So with that, please take a look at some of the resources available out there. We've got the SageMaker Jumpstart product detail page, which has got a bunch of details on the different foundation model offerings we have. We also have a great example repository that you can use to get started. And then if you want to actually go and fine-tune a Llama 3.2 model as seen in this demo, you can actually take a look at the blog that we've recently released. And yeah, so with that, I'll hand it over to Maren to actually provide some of the exciting details that Intuit's doing with fine-tuning on SageMaker.
Thanks, Mark. Hello, everyone. My name is Maren Kurian. I'm a distinguished engineer at Intuit. I lead the AI platform that supports both the generative AI as well as traditional AI workloads for Intuit products. Before we go into the details of our use case, I just wanted to introduce you to Intuit. Intuit's strategy is to be the AI-driven expert platform. Our mission is to power prosperity around the world. As part of our strategy, we want to develop the platform that serves our 100 million small business, consumers, and mid-market customers in such a way that they are able to make more money, save time doing less work, and make financial decisions with complete confidence. So we have been leveraging AI/ML capabilities to power our product experiences. Some of you may be familiar with QuickBooks and TurboTax. I've shown a few examples. In this case, there is automated data extraction from receipts in QuickBooks. There's cash flow forecasting in QuickBooks, as well as automated data entry from your W-2s and 1099s into TurboTax. In September 2023, Intuit launched Intuit Assist. This is our generative AI-powered financial assistant across our portfolio of products: TurboTax, Credit Karma, QuickBooks, and MailChimp. So here's a high-level overview of our platform. We have 95 petabytes of data in our lake. We generate 60 billion machine learning predictions every day. We have 60,000 attributes per consumer and close to 600,000 attributes per small business that they have shared with us, enabling us to personalize our product experiences for them. And we embrace thereof generative AI, making 10+ large language models available on our platform for our engineers to develop Intuit Assist experiences, resulting in 12 million interactions per month on Intuit Assist. So now let's go into the use case for fine-tuning. For that, I need to introduce you to QuickBooks. QuickBooks is the leading financial management solution for small businesses in North America. Over 7 million small businesses use QuickBooks globally. What you see here is the homepage of a QuickBooks company. As a small business owner, you would have set up your QuickBooks, you will connect your bank accounts, and your transaction feed starts coming in. Once you start categorizing your transactions, accounting happens behind the scenes, and QuickBooks will generate your financial reports. So what you see are the nice-looking dashboards that provide you insights on your financial status from the transactions QuickBooks categorized and accounted for. You can see profit and loss, expense sales for the last 30 days, your latest accounts payable and accounts receivable snapshot in the screen. So for this to happen, it's not magic. There's one important step between the transaction feed coming in and QuickBooks doing accounting for you. And that step is the categorization of transactions. So I want to show you what I mean by categorizing transactions. In this screen, you're seeing a list of transactions. Let's focus on the top 4. This first one says, Books by Bessie, you have got $55 on 11/21. Now, if this is indeed a sales transaction for your business, then you need to account for it correctly. You cannot leave it as uncategorized income. So you would change it to sales to indicate that this is indeed revenue for your business. Likewise, the third and fourth transactions are some expenses for your business which are related to rental in September and October. If these are indeed rental expenses, for you as a small business owner, for example, it could be rent for your office space or rent for your equipment, you might be eligible for tax deductions. So you need to account for them correctly by categorizing them as rental expense. So here is the customer problem. Going through every single transaction, categorizing them one at a time manually is an extremely time-consuming process. So if you're a really successful small business, you might have hundreds or even thousands of transactions every week that you will have to categorize, spending hours. And this is time that you should be instead focusing on your business. So fortunately, that's not the case. QuickBooks has been continuously innovating in this space to make this transaction categorization as easy as possible. Years ago, we started with rule-based systems where you as a small business owner would be able to create rules based on the patterns for particular transaction types or payee types so that QuickBooks automatically categorizes them for you. The problem again is rules need to be created manually. It is cumbersome. And if you have a large number of business partners, it is still time-consuming for you as a business. So our latest solution that's running in production is based on traditional ML, and it predicts the categories based on your history of categorizing transactions. We will look at it in a while, but I wanted to set some context on why this is a hard problem. So by this time, you have probably guessed that this is an n-class classification problem. So within a small business, you have n categories to which the transactions need to be assigned. Now, what makes it hard is that this n is unique per small business, and we have millions of small businesses that QuickBooks serves. So there is huge variability in the way small businesses do accounting, and each business uses QuickBooks in their own way. Also, a small business is an extremely dynamic and fluid ecosystem, and their accounting needs reflect this. They need to change how they do accounting as the business keeps growing or shrinking, hiring employees or letting them go, or if they expand to new regions, incurring payroll-related expenses or payroll-related tax deductions, or incorporating new types of sales tax rates for various cities, counties, and states. Needless to say, the way a dentist practice would do accounting will be completely different from how a landscape practice does accounting. So one could argue that we can use their previously categorized transactions as ground truth to train these models to make predictions for future transactions. Now the challenge here is that only a small fraction of small business users actually hire professional accountants to keep their books organized. So the quality of the label data is a challenge. So the ideal solution is that QuickBooks automatically understands the details of how you do business. It understands the intent and purpose of every transaction that comes in, and it automatically identifies the right category. And as a user, you just need to review and confirm the choices. So from hours working through the list of transactions, you can take a quick peek, confirm, and review. Okay, so this is our existing solution. As I promised, I'll share. We have a combination of a populational model and a large number of personalized models, all traditional ML based. We hit the limits of improving accuracy of the solution, as there's only so much data that we could train on if you're only relying on customer data. And our model architectures were small. So the accuracy has not improved in quite some time. And since the model architectures were small, these wouldn't generalize well. So we, in fact, have one personalized model per small business to do transaction categorization. So that's about 4 million models that we are continuously maintaining in production, adding to operational overhead. As I indicated earlier, high-quality data for ground truth is a real challenge. So we require this in large amounts to maintain these models by continuously training them. Now, given all of this context, large language models offered completely new ways to approach this problem space. Large language models are very flexible, they are versatile, and therefore it was significantly easier to formulate the problem and leverage a wide variety of data sources using LLMs, as we don't have to worry so much about shaping the data into fitting the smaller model architectures. LLMs, of course, know a lot about the world. They know accounting, they know various types of industries and business types. So all of that information was extremely useful. So we started with prompt engineering, testing commercial off-the-shelf LLMs with a large variety of our data sets. And our early tests showed increase in accuracy. As I said, this was exciting because we had hit the limits of improving accuracy with our previous system. So the team got really excited. They started experimenting with various combinations of data sets. For example, few short samples, chain of thought, reasoning samples, industry information, and historical data on how categorization is done. But then we started hitting the limits of the commercial LLMs. We started running into context windows sizes, increased latency, and scale challenges. So that is when we shifted our focus to evaluate open weights models, as they provide a lot more options to customize them. Our goal then was to build a model specialized in categorizing transactions for our millions of small business customers. This was a new scenario. We had not previously fine-tuned a foundation model for very specific tasks. So some of our initial challenges were in gathering evidence of the feasibility of this approach. So this included a lot of experimentation to provide strategic direction for further investments. Once we got confirmation that it was indeed a right approach, Then the next set of challenges is in keeping up with a variety of models emerging every other week, doing evaluations, narrowing down the models to fine-tune on. We also had a large number of stakeholders who needed to be updated and a large number of ideas to test. So it was important to move with velocity. So the team doubled down on the approach of rapid experimentation and fast decision making to systematically test out all the ideas, eliminate the ones which didn't show promise, and choose the best ones to further fine-tune. And this is where SageMaker really accelerated our journey. We leaned in heavily on the boilerplate code and infrastructure tooling provided by SageMaker. This accelerated our initial model evaluation. Once the team built the data pipeline, they were able to run experiments quickly to choose the base model to fine-tune. SageMaker also provides a sandbox environment for us to securely explore from the large number of latest models. This is important to us to meet our responsible AI and data governance standards handling customer data. Continuous training capabilities helped us run several experiments with various combinations of data, layering one experiment on top of the other. In summary, we fine-tuned 10 plus models using LoRa in a matter of a few weeks. And now we are working on scaling out hosting for our millions of customers using the inference solutions SageMaker offers. So if you recall, we had 3 main challenges with our traditional ML-based system. The accuracy was not improving. We had operational complexity, maintaining millions of models in production, and the lack of ground truth. I'm happy to share that our fine-tuned models, the early wins with that, show promise for production use at scale. We are seeing that the models are able to show 5 to 10% improvement in accuracy across different populations. In traditional ML scenario, we had to use millions of samples to train those models, whereas with LLMs, we only needed thousands of samples. And again, as we saw earlier, we operate 4 million personalized models, 1 per small business. With a fine-tuned model, we can potentially replace that solution, reducing operational complexity. In addition, SageMaker provides options for cost-effective inference. So we are set up for enabling huge scale. This was one of the first use cases for providing a fine-tuned foundational model for specific task attitude. So this use case is now blazing the trail for more to follow. And with the data pipeline in place, team is now able to evaluate newer models as and when they are available, enabling velocity. So here is how we are planning to roll out this in production. We are not completely replacing the existing solution as is. We are taking a hybrid approach, doing a gradual rollout. So our existing solution will still first categorize the model, generate a confidence score. If the confidence score is high, no further action is needed. But if the confidence score is low, then we can rely on the fine-tuned model to generate the categorization. And once the categorization is generated, we can send it for customer review. I want to close by highlighting a few learnings from this use case. Due to the variability in accounting practices across small businesses, we needed a large data set with thousands of samples to meet the criteria we had for accuracy. Typically, you would hear that fine-tuning only requires hundreds of samples. In this specific example, that was not the case. Synthetic data also didn't help, again, for this use case, as we needed to use real customer data to have coverage across a broad range of scenarios. So why did we do fine-tuning? Fine-tuning provided us the ability to manage accuracy, latency, and scale required for our customer experience. Large amount of contextual data was needed, in this case, for doing inference. And in our experience, if you have the right use case and the right data set, fine-tuning is a cost-effective way to experiment with LLMs. We embrace rapid experimentation as our approach to quickly learn, pivot, and refine our ideas and iterate in this emerging space. So this use case paves the road for task-specific fine-tuning at Intuit, and we hope to do more in future. That's all I had. Thank you.